Record. Hi, welcome to our technical interview. My name is Ed. What is your name?
My name's Kenny. Nice to meet you.
Nice to meet you too. Today we may be doing a series of problems. Just to test and see what you do now. I have prepared for you a problem related to binary trees. And it is specifically titled invert binary tree. So basically, given the root of a binary tree, we invert it and return its root, the parent, basically. Okay. So basically, if we look at this diagram, like of you can so like for example, if we're going like left to right, or like in terms of inserting, like what the inputs are, we have like 4, and then we have 2, 7,
okay.
1, 3, 6, 9. So and the output should be kind of like in the reverse order of that. We're returning a tree node pointer. Yeah, because we're returning the root. And yeah.
Okay. So basically, just to make sure I understand this correctly, is you have like a tree, just a really small example, and by invert you mean turning it into you're just swapping the left and right nodes. Oops. Like that.
That is right.
Okay.
So naturally, this does not follow a BST, because yeah.
Is the original one I'm starting with a binary search tree, or I guess it really matter?
It doesn't necessarily matter, but in the examples that are given, yes, I believe, yeah, we do start with a BST, a binary search tree.
And am I only considering? Is my only goal, I'm just like not even interacting with any of the data in the tree. I'm just inverting the entire tree as a whole.
Yeah, so you can go at this in several ways. Sorry, what was the question?
I guess like, and do I have to do anything with the data in the tree? So for example, like this is integers. Do I even like need to? Like what I'm trying to do is just like swap these, right?
Yes.
Okay.
So one idea I do have, I think, just now is maybe like, ooh, what if like you put them in like a vector, something like anytime if you go row by row, and yeah, you can have like a null value. So oh yeah, the constraints that we have is that the number of nodes in the tree is in a range from 0 to 100, and the value of the nodes, which are integers, they are between -100 and 100 inclusive. So it could be -100 or 100 and somewhere between there. But you can't have like 1,000. So use that if you want to have some sort of potential with null values. We can put that in like a vector, right? Like NULL, like capitalize.
Yes.
Even if we can't, we can put as a value that's outside of the node range.
You brought up the numbers, so I'm just curious, like, put the numbers back. Since this is a BST, is this also just going to be a reverse BST with my lower numbers on the right and then my higher numbers on the left? Is that what the question's asking?
Essentially, well, it's based off the original. So if you were to try to draw like this.
Yeah. That's really good.
Well, even though this will be an invalid BST, well, is it? Oh, it's 1.5. I thought it was 15. Yeah, this is, yeah. So I'd say yes, that's an example. That's like a perfect example of inverting.
Okay.
Yeah. Hmm.
Okay. I think one way that you could solve this, would be to really just iterate through every single node of the array. And then just swap.
You mean
or
from
not
the tree
array,
node?
the trees.
Mm-hmm.
Go through every single node of the tree and then just swap the left and right nodes. And it should work correctly. I do wonder though, if you had a tree. If you had a tree. And if you just, it only has one child, for example. When you invert this, does inverting one child mean going from left to right and right to left?
If you sorry, what?
If you only have one child, a one child node, and like let's say like this is pointing to null.
Yeah.
This is my new one on this end. Is this what it wants? I guess.
I believe so. Anytime it's kind of like a mirror in a sense. If we were to draw a physical line down here. So I think that a good idea perhaps is so when we try to like do like a left equals right, right equals left, one thing is going to be overridden with the other. So I think that we might have to create like a temporary node pointer to store a node and then like the value or maybe or yeah, I think a node pointer would work. um do you understand where I'm going with this, perhaps as a hint, like a temporary circle?
Yeah, like you would make a, I don't know, like a tree node that's just a temporary and
Well,
is that what you mean? Like
what I mean is so tree node is includes a struct, includes pointers to left and right. Okay, so I guess it doesn't include node as a thing. It just has pointer. Okay, so it has just tree node pointer. So you were right. So I was thinking a pointer. So we create like a right. Guess we have to delete this again. I don't know. Temp or just T is equal to new tree node. And basically, so I think you have a right idea about switching. Like so, for example, if we have this one is like 1, 0, and 2, and what we want to get in the end is 1, 2, and 0, right? Just want to make sure not going too fast. That's cool. We want to make something like this original is like what is gonna say um the what should we call root, right? Root left is equal to root right, like we want to switch and we don't have root right is equal to root left. Right, that's how we gonna want to switch, but we can't because as soon as we have is equal to right, and we're gonna have right is equal to right here, basically. So I think that the first thing we do before all of this is that we insert this line. So this comes after this. Um, um, is that we have like T is equal to, I don't know, we can store one of them, root left. Actually, no, hold on. Yes, root left. So basically, we're gonna create this extra circle, T. It's gonna, T, so let's write it right over here. And then it's gonna look at this, the root left, right? This is the root in here. And so now this is gonna point there. And it has a left and a right because of the tree node. And then let's see, this one's left is not gonna be equal to its right. So we can do like left equals to right. So this one, I'm just put L and R. Maybe that's be kind of good. And so right now we have as of this instance, second step, we have two L's, and this is like this one's pointing to hold on. Oh wait, no, this is R already, right?
I think I know what you're trying to do.
Right, and then we do this. We have this is gonna input it the right. So instead of left here, it'll be like C. What should we? I don't know. What should we put a T left? Something like some can't. Can we just like do like T? We do like T left. Those like points to. We do that.
Although I think I'm gonna.
Oh, okay. This is just one idea. I just thought maybe you might have something better.
I think you're doing good.
And you have to do this recursively, basically. I think.
Yeah. I'm going to erase the example tree, and I'm going to start writing my pseudo.
Okay, cool.
So I think the easiest way to actually do this would be to have two functions. You have one function that like goes through the tree recursively. So like through each version, through each node, either like through a depth first search or a breadth first search, just like access every node. And then you can have a second function that actually swaps the left and right nodes. And then you can just call that whenever you go to one node.
Okay.
And I'm gonna start actually with the second one because I thought that'd be easier. So I'm gonna make oops, that's not so one, and you can give it true. No.
Maybe root would be a good word to have that. I don't know.
It won't really matter, but it's
Yeah.
and basically I'm just gonna do like a similar sort of thing. So I'll give it a node for I guess first things first. I want to write tree node. I'm gonna call it temp. And I'm gonna make it equal just like to left of me.
Like I said, we don't have to allocate on the heap. We can just do on the stack.
Yeah.
Yeah. All right.
And then, so basically, I'm using there. And then what we want to do is set root dot left equal to Alright, I think that does what it wants, right? You start with the root and make it something.
Trying to just use letters for in this example.
And this points here initially, and then the last, this one will point there. So we're gonna have right R C, and then I just choose right to point to that. Alright, that works. That's one function, and the other function needs to be one of order traversals. So you could do any of them.
So, I'm just thinking like how much time has passed. Maybe like 10 minutes.
Do you know which time you started?
I don't remember. I feel like it's been. How long was my explanation? An explanation of the problem plus me trying to
I think it's
use
been at least
12 minutes,
15.
15 minutes.
So if you're looking at
All right, so I think we're at a good pace.
Yeah.
All right.
Anyway.
What was that all about?
Lost my train of thought.
Oh, I'm sorry.
You're good. Okay.
Recursively.
I meant traversal. Traversal, recursive. And I need to take in a root. Alright. So I guess first things first.
You're the realist.
um,
Cough. I don't like sparkling water.
Yeah.
I say cough a lot. I'm joking. What year are you? What year are you in?
Sophomore.
Oh, I'm a junior.
Oh, really?
Yes.
Are you a computer science major?
Mhm. And what about you?
Hmm?
What about you?
I am too.
Cool. Let's go.
And you need to check out return. And then just want to call.
To return nothing.
I want to call.
Wait, what would be swapping? The left and right of a no is still no. I think we just want to return. We want to go back up.
Oh yeah.
Right, but no, but
Because I wanna do
if it's no, if the root like, I thought like we're going down a tree, and like like let's say we keep
The
going.
way I was thinking it is, I'm trying to think of like what traversal I remember the most, which is in order. Unfortunately, I don't remember.
No, but
And then
pre-order is just you switch where the main action is. It's always LR, but like so in order it's on the inside. Pre-order it's like it's before everything. It's the first thing. Post order is what's the last thing.
I don't think that order really matters because you're only looking on it at like 3 notes at a time. So if you start at the bottom of the tree, you can recursively get all the way to, and then I know you're right. I'm doing this wrong.
I wonder if we should if it's level breadth shirts level by
Masters
level.
would be better. Just because you can look at each specific one. But I don't quite remember how to implement that.
It's with it. So you can do like a queue structure,
I remember the queue. But
and
whoops.
wait a minute.
This.
Oh my god. Swamp nodes. You can call that recursively. Inside it, like if it has a root left, you call root left until all the way until it reaches a let's see. Basically, if you get all the way down to like here, you can't swap anything.
Mm-hmm.
So, but let's say we get that up to here, we can. How can we check if it's like one level above below?
Oh, wait.
Like we can check if like the next of like something is like null, and like this one's also null, and like this one's also null, and this one is also null. Hold on. If we start up here, then we can call this right, be the left, this left, right. And we also have to split these two, and then if it has children, I think we are onto something here. We'll reduce that from the top of the bottom, but I'm not so sure if we have to like check 2 levels in advance.
I get your opinion. I think it'd be easier for you to get rid of this thing. So I'm only swapping, and I could turn this into a cursive function. And basically kind of just do what you suggested, just like that is not equal to null, then I want you to do it again.
With root left. Oh,
Yeah.
so that's how we keep going down.
And
Wait. Do we want to check that before we do, like even even before we create the temp? Oh wait,
I don't think it matters, to be honest. You're just
because actually no. Hold up. If we did the if statement first, we get all the way down to the bottom.
yeah.
We keep on going down to the left.
I'm not 100% sure if that works, but the other idea that you do the same thing for the right. I'm just gonna write it down.
Is there an answer later on?
Should I feel like it might be a little finicky, or how to bugs, because
You can start off by just doing
yeah. So right now,
letters.
check more
Right.
colors. Well,
Yeah.
it's my temp image, and then blah blah blah. Basically, these two are getting swapped. So this becomes right, this becomes left, and then left. Yeah, and it,
We want to, yeah, I think that's a good notation of having switching the R and the L every time. Does that sound good? So now, what happens if we reach the first if statement?
yeah, when you reach the first statement is this is what it's gonna look like, and then you can put on left just to already swap them. And then here, or back here, there's no nodes. I don't know why I just drew.
Yeah, she just lied. Like, bro, actually, we creating notes in the process.
Okay, no nodes. Well,
Then
that.
it's that.
I think
Well, it's not equal to null pointer. No, it is equal to null pointer, so the if statement doesn't work.
what I should do.
So what happens? Okay, so then we go to the next if
I'm gonna do
statement.
something first, adding
Okay.
I'm adding one node
Mhm.
to the left. So fruit.
Wait,
Yeah.
so then
And
wait.
right. No, it should still swap. This would just become right and left. Just
Wait, you went through the recursion in swap nodes route?
yeah.
Okay. Hmm. That does make sense.
And yeah, that'd just be null. Because the node is null, and then just swap it null. That's right, that's left. And then over here, it's going to the right, and it's going to swap left and right.
Hmm.
I think that works.
This feels like it works.
And it's gonna go all the way through until it reaches the bottom, but it's just gonna swap null with null. Which doesn't really make a difference. What you could do, if you didn't want it to do that, you could add like
Oh,
an if statement, like if it's null, then
no,
don't
and
do it.
if it well,
Actually,
I think that at the end of after your second if statement, there should be a return route. Because we actually yeah, we're supposed to return something. We're supposed to return tree node pointer. So it's not void at all. If we want to make we can make this invert
what are we
tree.
trying to, why would we return the tree node pointer? Is it just like, is that just to access the tree again?
Yeah, it says we want to return like the root, like the actual parents.
Okay,
So if you want, this could be actually the function that we call, and this is all the details. We're just calling recursively.
well, it doesn't look redundant, that we could just like return through at the end of it.
Hmm?
And that's the same route that they gave you.
Hold on, so let's see. You want to do like another example of like 1 and then a 2 on the second level? So and this time let's try to like fill it with numbers instead so that maybe we can well, I don't know about if we want to do multiple levels. Let's like start off like simple, maybe.
One up.
Or I don't know. What would be a good example?
2, 1, 3. Yeah, hey, whatever. Temp
Right.
node. And then immediately comes to 1, so it's 2 more times. And then my root left is going to my root right, so this actually comes left. And then my root right is temp. So it's my right. Cool. And then we go in recursively within this node, and the same sort of process.
All right. So what happens if we want in the first if statement, the left is not equal to no pointer, so like the 3, and we do swap left, and so we're swapping null and null, and then we go into the if statement again. This time, the left is equal to no pointer, and the right is equal to no pointer. We return root, so we return 3. And then afterwards, let's see. Then so this is like we will return 3 because at the end is like no for these two. So we go to return 3. Now it's this for this one. Now we go to this one, return right. This is this one, and it's the right is not equal to no pointer because it equals to 1. And so then we go through this again. At the top, left is equal to null. Right is equal to null, so you're just swapping nulls. And then you go through here. Root left is not equal to null. That's false. This one is also equal to false. This one is also not going to be true because the right one is going to be a null pointer. And we return roots. So we return this one, and then yeah, then we return root again because when you traverse to traverse through the left from 2 being the roots. So like, okay, I'm just gonna explain this a bit better this time. By writing the numbers of what is root at the top.
Yeah.
Okay. Or if you want, you can try doing that. Like, so I don't know. Do you feel like I think this makes sense. Like this is a good explanation. You don't have to explain it anymore. I feel like this is solved. What do you think?
I think it makes sense. I think,
If you
Like, if
want to
it just
explain
wants-
if you wanted to explain further detail, I think that would be nice to write down what is root equal to at the top every time. And then to iterate it, like put it back again and again and again. So
yeah. I feel like it might be a little, for the way I did it, it might be a little redundant because at least I'm just returning the parameter, which I basically just mirrored. I just mirrored this.
that's the point.
So,
We were just-
I mean, if I would change this, I would just streamline this, I just wouldn't return it, I just change it to void and return nothing. Cause then this would just swap everything.
well,
with this.
and the question just asked for you to return the
Yeah,
root anyways, but you're right. In like actual implementation, you could make it such that, hey, just know that when you're inverting this tree, when you're mirroring it, the root is just the same. I think it's like a valid function thing. But yeah, congrats. I believe you are done. Now, just a little bit of interviewer kind of like feedback. I feel like your approach to this problem was excellent. The way that you went across your function was pretty good. I think one weakness, let's see. I think that you did ask for help when, or at least I butt in, but so I guess if we're being real here, like, did you want like hints at the beginning?
I think hints helped me get a better idea of what exactly I needed to do, so I think they were helpful. I think
Okay.
it was helpful.
But like, ideally, would you have like, because I feel like I kind of went in
I
without.
think it helped me get to the answer faster, but I probably could have made it, it just would took me a little longer.
Right. Okay. But I guess the only real weakness or whatever, just thing that we can improve on is to ask perhaps if you feel, or like, I don't know, you probably could have gone to the answer. I just felt like something that I saw, and this is something that I also could have been wrong about it easily. But my idea. But in the end, you fact checked it, and so in the end, this is your solution. And yeah, I think this looks good to me. You have completed this session. Thank you very much for coming to our interview, and is it. Bye. Let's see. Stop recording.